Hello and welcome to Module 14. I'm your professor, Dr. English Dowdell. Now, in this lecture, we're diving into a very important concept in modern software development, which is graphical user interfaces and event-driven programming. Now, by the end of this lesson, you should be able to explain how graphical user interfaces, or GUI, as we call them, applications react to user actions. You should be able to map events to program logic and write simple pseudocode for event handlers. Now, we're also going to connect this to your milestone for the week, which is creating your tests, your system test plan. So you'll understand exactly what to test and how GUI events influence what you need to check. Okay, so let's start off with the basics. Now, GUI, which is GUI, the acronym GUI, we pronounce it GUI, stands for Graphical User Interface. Now, this is everything the user sees and interacts with. So that includes like buttons and menus and text boxes and labels and drop-down lists and icons and so on. Now, the key idea behind GUI design is that the user doesn't type commands. Instead, they click or tap or drag on selected options on the screen. Now, what makes GUI programs unique is that the program waits for the user to do something. So basically, the user is in control. And this leads us straight into event-driven programming. And when we talk about event-driven programming, this means that your program reacts to events. These are things that the user does. So an event is any action that's like clicking a button, hovering a mouse, typing in a box, submitting a form, selecting a menu item, and even when, say, a timer finishes. Now, when an event happens, the program triggers a piece of logic called an event handler. And this is code that responds to the event. So an example again of events would be like a button click, okay, a mouse over, key press, form submitted, unload. So basically in simple terms, an event happens, then an event handler runs, and then the program responds. Now, to help organize your thinking, developers often use event diagrams. Um, an event diagram is going to show the GUI element, which could be like the button, the text box, the menu. It's going to show the event. So that would be like the click, the input, the selection, and then it's going to show the logic that should run in response. So imagine, for example, a calculate button on a form. So the event diagram is going to show as far as the GUI element, which is going to be the calculate button. That's the GUI element. And then it's going to show the event, which is going to be like your unclick event. And then it's going to show the logic that is going to happen. So it's going to retrieve the input, it's going to perform calculation, and then it's going to display the result. Now, event diagrams, they help you think through like which actions your users can take and what the program should do, say, in each situation. Now, let me just go over as far as like the basic guidelines that you can use when you're creating an event diagram. So one, you're going to start with the user action. Okay, so you're going to put the user's action at the very top of the diagram. And this is usually written inside of like a rounded rectangle because it basically starts the flow. So examples of user actions could be a user clicks a button, or a user types in a text box, or user selects an item from a menu, or maybe the user submits a form. Okay. The second thing is then you show the event that's going to get triggered. Okay. So for instance, in our situation here, it's the unclick. Okay, so we show this below the user action, and we draw a rectangle, like a regular rectangle, to represent the event. And this is going to describe again what event fired in the system. Okay, so examples of that would be like whatever the button name is, like in our instance here, calculate button dot unclick, or if it's a text box dot unchange, menu item dot on select, form dot on submit. Basically, this box answers like which event is the program listening for. Okay. Now, the third step is that we would list the logic or the steps that are going to be run. So below the event, we're going to draw one or more rectangles to show like what happened when the event fires. And this is the event handler's logic. So examples of that would be retrieve inputs, validate data, perform calculation, maybe even save information, display a message, or update the screen. Now you can use one rectangle for all of the logic, and combine them all in one rectangle. Or like in my example here, you can have multiple rectangles to break it up step by step. Then the next thing you want to do is to connect the boxes or connect everything with arrows. So we use arrows to show the direction of the flow from the user action to the event to the logic. Okay, so your diagram should look like a simple, say, vertical chain. Okay, and this shows the program reacting only when, say, the user does something, which is the core idea of the event-driven programming. Now, the thing is, you want to keep your labels simple. Okay, each box should contain only a short phrase. So what you want to do is you want to avoid like long explanations inside of the shapes. So some good examples of that would be user clicks login. Or login button dot on click, validate credentials, show error messages. And then you want to follow or stick with standard shapes. So the standard shapes would be, again, your rounded rectangles would be the start or the user action. Okay, a regular rectangle, this would be your events and your logic steps. And then you would have arrows that show the flow of control. And this makes diagrams easy to understand and it makes it consistent across all projects. Now, event pseudocode focuses on defining what happens when an event occurs. So the structure is really simple. It's like basically when the event occurs on control, then you show the actions or the steps that get performed and then an end when. So here's an example using a login button. So there's a couple of ways you can write this, which would be acceptable. You could either say when on click occurs on login button. Or like I've written it here as sort of a shortcut, when login button dot click, and then these would be the steps that would be performed. You would input the username and the password, and then if valid, they would get a success message, else they would get an error message, and then end when. Now notice we're not writing a whole program. We're only writing the logic that happens, say, when this particular event happens. Now in this week's milestone, you're to build your system test plan. Now this test plan will verify that your logic works the way that you intended. Now since GUIs trigger events, your test cases should reflect user actions. Now, a good test plan is going to include three things. It's going to include the sample input, that's what the user is going to enter or click, okay? It's going to include the expected output, that's what the system should do. And then it's going to include what you're checking. This is the specific piece of logic that's being verified. So for your project, each function needs to have at least three test cases. So basically ask yourself, what can the user do here? And how might they break it? Okay, that's how you build a strong test plan. Okay, so here's an example of how you would record the information in a test case table. So remember, you're recording like sample input, you're recording expected output, and then you're recording like what you're checking. Okay, so for example, in this first one here, what we're testing, okay, we're actually testing the add item button. Okay, and so as far as the and this is the add item button click we're testing. So for input, the user would enter the word milk. Okay. Um, and then they would click the add button. Okay. And so as far as expected outcome, we're expecting that the item is going to be added to a list. And then as far as what we're checking the event triggers, correct function, and updates the display. Okay, so this is how you would write as far as like a test case table so that you know what you're actually testing. Okay, so like for instance, another example could be that we're testing maybe a calculation function. Okay, so the function that would be tested would be like maybe the calculate total. Maybe we have a calculate total. Um, and so basically the input would be we'd be entering like different prices, like 10 or 20 or whatever the case is. And then the output would be like what would we expect? So if we're adding, if our input is 10, 20, and maybe 5, okay, our expected output would be the number 35, right? And then we'd say what we're checking that the calculation logic adds correctly. Okay, so we're checking the calculate total, and we're saying that our input is 10, 20, and 5. Our expected output is those added together, which would be 35. That's what we're expecting. And this is just basically checking that the calculation logic adds. If we were doing maybe a test case for like maybe error handling, okay, where what we're looking at is the save button click maybe, okay, to see if it produces an error when there's a problem. So maybe our input would be that the user would leave maybe the input box blank. Okay, so that would be our input. And then our expected is we're expecting to get an error message. We're expecting that an error message is going to get displayed. That's our expected output. And so basically what we're checking is we're checking the validation event handler that validation event handler actually activates. So again, what you need to do is ask yourself, what can the user do here? Okay, what can they do? What information are they going to put in? What is our expected outcome? And what is it that we're actually checking with our test? Now, after you create your test plan, I want you to share your progress with your classmates. Now, I don't want you to just post your document. I want you to summarize the challenges that you faced and any parts that you're unsure about. And then, of course, you need to respond to at least two of your classmates with meaningful suggestions. Now, your goal is to basically kind of help each other identify any kind of gaps before you do a final submission. Okay, so before we wrap it up, I just want to practice again creating event handlers because this is going to be important. So I want you to imagine a submit button on a form where users would enter comments. Okay, so think about what should happen when they click submit. Okay, so here's our pseudocode. So when submit button click, they're going to input a comment, okay? And if the comment is empty, then what you want to do is display comment required. Else, you want to save the comment and then display thank you for your feedback. So this is exactly the kind of logic that you'll test in your milestone. Okay, did they leave the comment empty? That's testing the validation of the comment. And then if they did, the expected result would be what? To display comment required. Okay, that's checking the validation. And then if you're checking the successful submission of the submit form, then it would be okay. The user would actually enter, and then you would show maybe some test data, like show an example of what they would enter. This is nice, something like that. And then your expected outcome is to that the comment would be saved, and you would display thank you for your feedback. Okay, and then that's what you would be checking. Okay, so to quickly summarize, GUI programs respond to events, and event handlers define the logic that happens when the user interacts with the program. Test plans are going to verify each of those logical steps. Okay, and then again, you're going to apply this to the milestone for this week. So again, just to review, so this week you're going to read chapter 15 in a textbook. You've got a discussion, which is the project progress update, and then you've got your milestone. So this week you're going to apply the different ideas that we talked about by creating a test plan that includes sample input, okay, expected outputs, and the logic that you're verifying. Now make sure that your test cases align with the events and the functions in your system. Now, if you have any questions or you want feedback, reach out early. So let's get started with Module 14. We've only got a few more to go, and have a good week.